Welcome, everybody. We're right on time, I believe. I am Mike Nagler, Superintendent of Mineola. I warn you that a lot of things I say might be, are completely from a perspective of leading a district. So I gotta start off with framing the problem from a perspective of leading a K-12 system. So this is kind of the agenda for the session. Is I want to speak about who, what, where, and how in districts, and we need to talk about the why. I think one of our biggest issues in trying to scale for all is the notion of why are we doing it? Why is it important? Why do we have to do it? And not assume that everybody knows the answer to that, because they don't. And we have to take the time before we implement things to really speak about the why. The who, I know I'm talking to teachers and it's a teacher organization, but I don't think enough of you exist. So we need to also think about creative methods for leveraging your expertise and perhaps partnerships of people outside of our school districts. The what is the standards? Are the standards enough? I'm hesitant to say that they are. What about actual coding languages? Should we spend time with that? And the practicality of doing both in a system. Where do we do this? My answer is everywhere. It has to be embedded in all of our content classes, or we're not going to be successful. And then where are those opportunities for real life applications? And I think that's a piece that we really got to talk about how to extend this outside of the classroom, and robotics has been a great one for us. And then lastly, how do we do it? It's got to be with partnerships and integrated curriculum, and we've had a lot of success in doing that. So I'm just going to pause for a moment to make sure everybody is seeing this. I'm going to stop and look at my chat. Could somebody just let me know that all worked? Thank you. Good. I hate to just talk to myself and not know what's going on. All right. So I'm going to start with why. And I think the big question with why is, what's the purpose of public education? Now, we had the second and third industrial revolution, and I think schools were really asked to create members of the workforce. Now, back in the day when we originated the notion of public education, it was more to be a citizen of a democracy. I think we moved away from that over the last 100 years or so. And as we're on the precipice of the fourth industrial revolution, where and how do we see what's going on change the role of public education? I think you have to look at certain things. One of them is, what's going on with labor. I don't think it's a secret that manufacturing and agriculture are on a downward turn, and they're prime for technology to take over. But while we see an increase in the service industry, we see a massive change in the service industry. When you think about, FANG, I don't know if you know that expression, FANG, there's Facebook, Amazon, Netflix, and Google, how they've disrupted how we deliver services. And Amazon, how many of us just send stuff to our home, and all the vacant stores in our communities, what's going into those stores? Odds are 9 out of 10 are some kind of service, and the predominance of service is the health industry. So how does that affect what we do in school? I think the other big thing that schools are very poor at accomplishing is the speed of innovation. We are getting quicker and quicker and faster of how technology is changing our lives, and schools are very slow to keep up. I don't think it's possible for them to keep up at that pace. I often talk about a 13, 14-year timeline from the time your student enters in pre-K to when they graduate. you know, the world has changed immensely while they're in school with us. And how are we adjusting when it comes to that? Now, and it also comes down to this notion of creative destruction. And this is really speaking about the fourth industrial revolution. And in the previous revolutions, we've seen, you know, as technology has come in and created new jobs, is that 13% on your right, it's eliminated kind of an equal amount. So we've automated things, but we created new things, and that's kind of equal. And everything in the middle, well, a little education will change it. With the advancements of artificial intelligence, you know, people are nervous that that's not going to happen. You're going to automate everything, and you know, the job future is not great. And I think we have to address that. I don't think it's alarmist as it appears, but I think we definitely need to address that. The great book, Human and Machine by Paul Daugherty, he speaks about the missing middle. Like where, when you, in this chart shows human activity only on the left and machine on the right, and the traits and those little boxes on top. But he talks about the missing middle. It's focusing on this this spot where humans and machines kind of complement each other, and train, explain, sustain, amplify. These are new areas of not only professions, but what the skills we need to teach our kids to excel in that middle zone. Another common term, not common, but another term I like is from this book, What to Do When Machines Do Everything, is this notion of a system of intelligence. How can we look at the combination of software, hardware, data, and humans to come up with what we need to teach our kids in school? I don't think there's any argument that school is different than when we went to school. There's this thing called the internet that certainly has changed the way we should think about delivering instruction. So the system of intelligence, I think, is a nice framework for what we should be thinking about in terms of teaching and learning. And at the heart of all that is computer science. And I don't want to minimize the standards, but you know, we try to put things in frameworks that doesn't always work for how we implement it. So I think it's a great basis to start from, but there's a ton of other pieces that need to be involved in creating what we want our learners to know and do. So I'm going to pause for a moment and just check out my chat box. Anybody have any questions on that, comments, want me to dive a little deeper in that before I continue? No, everybody's still there? You know, some kind of, I hate digital distance stuff. One person chat in the box right now. Okay, good. I'm just checking you're still alive. There we go. Okay, so I think in terms of design thinking, this is a great engineering model. It's been around forever, and I think we need to apply it to schools. And what I love about the notion of design thinking is, you know, you start with the problem. You empathize, you define a problem, and then you co-create, ideate, think about solutions. And it's messy. Most of the times you ideate, you don't come up with a solution. But then you prototype, you fail, you make mistakes, you go back to the drawing board and start over again. This framework for education in general, I think, is a great mindset to have in school. But when we talk about computer science, it's a scary topic to people, and I don't think it has to be. I think we just have to let kids make mistakes and play with ideas and see where it takes them. Now, a lot of people favor the notion of computational thinking, which I think becomes more concrete And when we use, words like abstraction and algorithms, it throws teachers and parents off. We do all of these things naturally. We don't necessarily define them in school, but we certainly can find examples of how we do this. And I think that's the bridge here. We want to find examples that currently exist of computational thinking, and then how are we branching that out into embedding our standards and what we want to do with CS. And also remember that it's a combination of a lot of things. I love this graphic by Digital Promise. They put it out a few years ago. It's not one thing or the other. It's all of them. And when we think about how we implement it, I don't think there's a right or wrong way to do it, but we're doing all of it, and it's not one standard or one piece as we move forward. We've taken this concept and we've designed our own acronym. Our mascot is the Mustang. We're the Mineola Mustang. So we took Mustang and we created this is a takeoff of Launch by John Spencer. How we break it down for kids. The one on the left is our elementary model. The one on the right is for our upper grades. So how do we do all of it? Well, we've created partnerships over the years, and we've done a full curriculum integration. And when you talk about K-12, this is imperative that we embed the skills and the standards in everything we do across our system. We have a fabulous relationship with Kidoyo. We've been building out that platform for years. The beauty about Kidoyo is it's an open source platform, so you don't only have to use it for CS. We use it for tons of things in Mineola, and they're a great company to work with. But more importantly, it provides us the K-12 platform. Our kids that work on stuff in pre-K and K on the platform, it stays with them, and it allows them to work independently over time for their whole school career. So if they want to move ahead, or they're not, they want to do something different, they want to learn a different language, all of that's possible. So it's totally competency based, and we're able to adapt it. And I'll give you some examples of that. We're very big on makerspaces. One of the first districts in the state to have a fab lab. It's a tricked out space for kids to have fun. That tweet is a picture of little snowmen that we make during the holidays. The elementary kids go to the high school and they create these mementos for their family, that each snowman is the height of that learner, and they personalize it. It's a great little thing we do on the holidays. And we're one of the few districts on the island to have all four pieces of the FIRST robotics. We start in 3rd and 4th grade with Lego League Junior. Our middle school does FLL with the Legos, and then we have a robust, and I know our teachers are on, Curry and Andrew Woosley do FTC and FRC. So we started this long before the standards came out. I think it was 2015. It may be 14. I'm not sure anymore. I'm getting old. I love this gear depiction. That's the work of Dr. Colella, who's now our high school principal. She was previously in charge of this implementation. And it kind of gave you the idea before the standards how we were thinking about growing the process of coding and language in a progression K-12. And one of the things I speak about is it changes constantly. But as you can imagine, when we go through it, we had to come up with, well, what are we actually doing in every class, and who's doing it, and where are they doing it? So the next piece is where. And you notice our thinking here. Our thinking was, all right, what are we going to cover? Where are we going to do it? And how are we going to do it? And we started with our librarians. The librarians were the key component of launching our coding initiative and our CS initiative. If you're not using librarians, you're missing the boat. They are a valued resource that is underutilized in many of our school districts. And it's another example of how we have to find teachers that aren't necessarily a CS discipline, but we can give them enough PD and support that they can do the job and they can do it well. We've worked with Kidoyo on the color by code and the MACE code. It used to be on paper and now it's fully in the system. One of the things about Kidoyo that is interesting is they become the CS experts. So I don't need my classroom teachers to know computer science. I don't need them to know coding, because when the kids do it on the platform, it's checked by, in the cloud by the Kidoyo team. Most of the Kidoyo team are college students that are in CS programs that are making extra money and doing this virtually. So there becomes this symbiosis between kids that are learning in school, helping kids in our K-12 system, and they're able to do this remotely and asynchronously on the platform. And I think that's one of the methods we really have to dive deeper in to scale this work, because we don't have enough teachers. And not every CS person is going to go into education. That's not where the money is. So how do we leverage the knowledge across the board to get this to scale? And the beauty about, here's another example, is we can create projects in content areas and not ask our classroom teachers to understand coding. We just need them to understand the content. So this is a partnership between the teachers and the experts in CS to create meaningful projects. And you can see this is across disciplines as we move up in our grade level. So I have a 3-4 building. We've switched the platform to Hatch, which is Scratch, OYO's version of Scratch, and they're learning to code in projects related to our subjects. And we continue that. The middle school becomes more robust as we continue with, and notice this is in every subject. So we're not asking, as we get into the departmentalization of school, we're not asking science teachers to go learn coding. We're asking them to apply the curricula they're working on and make some coding projects. And this really scales across the system. I'm going to take another pause here and see if you have any questions about that before. I'll give you a little demo of, I can't share the slides. So CS expertise from teachers unnecessary. I don't know that it's unnecessary. When we get to high school, it's certainly, I do have, I'm one of the few that have 2 CS certified people, Victoria Berkowitz and Curry DeFidi, but I also have 2 math teachers, Sabrina Knopf teaches CS for us, and I have a business teacher. So you can have different people and pockets in how you want them to scale the work. The teachers did the integrated projects, so they work together with Kidoyo to build off of these projects. So if you go into the OYO platform, they work on a concept of course badge. Everything is badged, and there's a course and a challenge associated to a badge. So these are our youngest learners. These are pre-K2 buildings, and this is color by code, and you can see there's tons of different badges they can earn. Now, over time, we've developed this with them to make learning pathways. So if you can see color by code, the first one on top, and the grayed out area, there's 1 course, but there's 7 challenges. Now, each challenge, you earn a different badge. But in the learning pathways, we've created this pathway, as the name suggests, that 7 badges equal a mastery badge, or an expertise, if you will, in color by code. And that first one, if you drill down into it, you can see Robot Blitz, Color Blocks 2, all 7 of those. When you complete them, you earn a mastery badge. And that takes you to the next level or next pathway in the progression. Now, what's important to realize is kids can do this independently. So I'll have kindergartners fly through this work where I'm doing it with some second graders, and kindergarten have already finished it. So it's very much, OYO stands for own your own. I like to say on your own. Either way, it's asynchronous. So you can work with the teachers, you can do a hybrid model, or you can be completely independent. It is a platform for all. And as we move forward, so who is doing the work? It's important, if you want to scale this across your district, that everybody has some ownership in this. So in addition to the classroom teachers, we find the special areas are definitely our go-to people. And librarians, we have STEAM teachers. Our kids rotate to science the same way they do art and music. So those STEAM teachers do a lot of work with CS and the concepts of CS, not necessarily the vocabulary of CS. In our middle school, years ago, we looked at that Part 100 requirement, and we developed a CTE strand, and we opened up a coding center. So we minimized family consumer science, and we married CS with technology. And we have a fab lab, and those 2 teachers work very closely with one another to create experiences for kids. And it's the first time we start to see this application, this real life stuff. How does CS and technology marry, like an Arduino? Can we program an Arduino to do something in our fab labs? At the high school, we've done a lot of stuff at the high school. So I'm very proud. When I was the principal of high school many years ago, and we had this Exploring Computer Science course. And those of you that are history people, the nation at risk, the computer science problem was identified in the 80s in the nation at risk document. And it was been ignored for 40 years. Some schools did this ECS program early on, but it really wasn't computer science. It was more, computers and the environment, and computers and society. I threw a gauntlet down to my team a few years ago that I wanted every single 9th grader to take AP Computer Science Principles. We did that last year. Every 9th grader took it. We're in our 2nd year of doing that. It was a hybrid alternate day model. It was asynchronous. The alternate day, you want to talk about a recipe for failure. I told our people, we're going to do this on an alternate day schedule and for every single kid. And that's the task. That's the challenge. No excuses. Let's do it. And we did it last year. Our results were mixed from the grade perspective of AP and College Board. But what I find very interesting is, if you're familiar with the AP Science Principles, 30% of the test is the create task. Our students knocked the create task out of the park. We exceeded, our average passing rate exceeded the national average and the state average. They fell down on the actual sitting down for the test piece, which we're modifying, and we have a course correction this year. So I'm excited to continue this. It's very doable. It sounds outrageous, but it's very doable. We also have electives and dual enrollment. We have asynchronous electives on the OYO platform with LIU Post. We have tons of in-school offerings. Again, I have the luxury of having 2 certified people, so I maximize that. We have an information technology strand that in partnership with Nassau Community College. We take in the junior year, it's a dual enrollment where the kids are in our high school earning credit. In their senior year, they literally go to campus 2 days a week. When they're not on campus, they do an internship with Core BTS, who's one of our other partners in this, and they do a rotation of marketing, sales, and technological services. So I put this up. The picture on the upper left is our coding center at our middle school, and what I found, now this is an old slide. So this is September 2018 to January 2019, and Lauren Goldfarb is the teacher at the middle school, and she's bragging about how many kids, 114 kids, already finished Hatch Level 1. So they went through that entire learning pathway, and this alarmed me because I did not expect that many learners to go through it that quickly. And what dawned upon us very quickly is as you roll this stuff out, it changes. So when you think you have a plan and you get to sit back, the whole thing gets blown up and you got a plan for the next 3 years. So when we started this in 2017, we were already talking about how it was going to change as we did well with our young ones, and they learned more and more in the younger grades. We had to change what we were teaching in the middle school. And that's what's allowed us to prep our kids for APCSP is they were learning it faster and earlier. So by the time they hit the high school, they already had a good foundation. All of them had a good foundation. The other thing that took off was our challenges. As I said before, we do all 4 of these. We have very big groups of kids in middle school. We can barely accommodate all the kids that want it. And so to give you, so I'm going to pause again and let me just take a look at some questions that we might have before I get into a little wrap up. There's so many questions. Sabrina from Kiddoyos telling you who you could talk to. Good. Are they learning CS on their own within HATS or applying integrated projects? So they do both. So they can learn it on their own, and they have their classroom projects. So the projects are mandatory. You know, I used to joke, you know, what's the purpose of doing a diorama, the old diorama? Let's get to some meaningful tasks, and you could still do the content and the skill-based stuff in coding. By the time they hit high school, you know, they're creating digital portfolios. Every kid graduates Mineola High School with a digital portfolio. We do it as a website so they could take it with them. We curate content for that portfolio as they go through the grades. What types of maker challenges do you put forth monthly? The maker challenges are more every 8th grader. 8th grade is in my high school, so I know it's a little unusual, but every 8th grader through the old ed tech, the Part 100 requirement in 7th and 8th grade, we do it all in 8th grade, and every 8th grader goes through the Fab Lab, and the Fab Lab will go through different mini modules. We just rewrote them this year. There's an Arduino piece, there's a coding piece, there's a building piece, and those things have all merged together that every kid has the experience. And I want to pause here to make an important, maybe obvious, but when you talk about CS for all, you can't rely on one great teacher. You have to have multiple teachers, but more importantly, you have to deliver the content in courses that every kid takes. So I talk about library, everyone goes to the library. I talk about science, everyone goes there. In the coding, every student cycles through coding in the middle school. High school, our Fab Lab in 8th grade, every kid goes through it. It's not haphazard. It can't be. If it's for all, and you talk about equity, you have to put the program in the spaces where every kid is exposed. And more importantly, every kid is exposed to the same content and the same experience. So if you have one great elementary teacher doing it, he or she's not scaling it to the whole grade. It's their class that's getting it. Well, that you can't brag about that. You have to be able to say that every student across your grade or across your building or across your district is getting a similar experience and the similar exposure to the content. And I think we miss that sometimes as organizations. So that's my plug for doing it in those opportunities. And you train those people up. You absolutely can give them the knowledge and the experience to leverage the work they need to do. They don't need to know, AP C+. You don't need that on the elementary level. You need to know how to navigate the platform we use, understand the coding language, and if not, how do I get the answers to that? So if I had to kind of summarize, let me get back to this PowerPoint. I advocate a multi-pronged approach. You need to do it in subject classes. You need to do it in special area classes. You need to have a platform that allows the K-12 continuum to happen. And you need an application of what's the knowledge I learned, how is it applied to my clubs and extracurricular. We recently added a CS Honor Society, coding clubs at the middle school and the high school. We were recognized for having more females. Oh, by the way, I brag that my 2 high school CS people are both female. We want more women in this field, and their role models are right there at our high school. We, by default, enroll every student in ASCSP, so therefore all of our females are represented. So we constantly win the gender recognition because it's for all. We make sure it's for all. Shameless plug, if you're interested in anything I said, I just released a book, so you can get not only the CS piece, but how we've implemented it across the board in multiple subjects in our district. And feel free to follow me or email me. So I'm going to stop this so we have some time to answer questions. Let me get rid of this. Okay, so ask away. We have about 5 minutes left. If you have any questions or I did not address anything that you wanted to ask me, or I didn't answer any questions, you have elementary lives fixed schedule, so they work in flexibly. Librarians do both. They work with teachers and they also have fixed classes. So it's a combo of both. I will drop the whole presentation so everybody can have that. Name of the book is Dev, D-E-V, Leader. It's a long name. If you Google Dev Nagler, it should come up. Do you have administrators or experienced CS? Yeah, our current high school principal was an engineer prior to her starting in education. So she's one of my rock stars in implementing this. I should have prefaced my entire conversation that I really don't know anything about it. I'm just an idea guy. I have big ideas and I give them to people. And I kind of, my mantra is let's look at the world our kindergartners are going to graduate into. So our constant conversations here are, what do we do to prepare kids for this world that is going to change? I like to use the example, if you graduated in 2020, you started school when the iPhone came out. And when the iPhone came out, 2013, around 2017, mobile devices overtook desktops, which doesn't sound like a big deal. But if you think about it, everyone's walking around with a phone, and on this phone, information is ubiquitous. And school did nothing about it. We continue to force feed kids content when they can, ask Siri. And that's going to put a turner on, so I'm going to put that down. What's our mindset? How do we think about the availability of knowledge that kids have, and what do we teach them to do with it? And all of that's based on CS. So it's a mind shift to what school should be like and the experience that kids have in school. We launched a new high school this year, a new version of high school where there are no periods. All of the subjects are in the cloud. Kids are accessing information and doing the work at their own pace, at their own time. That's kind of where school's going. So how do we leverage that and teach them the skills? And a lot of it's standards. It's the information literacy piece of the standards. It's the cybersecurity piece of the standards. How do you know what's good information? Those are all the next wave of knowledge we need to teach kids. So who's doing it and how they're doing it? You're addressing all the CS standards, K-12, you're focusing on coding. We're addressing all the standards. We can go back into, and I think Kiddoya did this. I think they took all the standards and tagged it in the work to show that the work our kids are doing organically cover the standards that they're asking to do. For me, the standards are great, but the standards should not dictate how we do things. If you're able to say, because most of us are doing things that are more robust than the standards and more meaningful to kids than, being able to do X, Y, Z. So I'm a big advocate of make it authentic for kids and then tie it back to the standards and show we're doing what we're supposed to do. Most of the times we're doing it better. You're finding a shortage of qualified teachers in CS. I don't think the CS teachers exist. I think I think there are plenty of people that can teach it. Are they certified? No, because the certification process is, it's in a quagmire right now. Are there plenty of math teachers that can do it? Sure. Business teachers? Sure. You just have to train them. I was not in favor. I was probably not popular with this group, but I was not in favor of the CS certification the way they're doing it. I really wanted an extension. I wanted a 12-credit extension like they do for, ENL or special ed. You can get this extension certification, and I think that was a lot more practical than making people go get 30 credits. We have tons of people that can do this. And do it very well. We just have to tap into them. Okay, I think I covered everything and in time. Yes, 5 minutes early. All right, appreciate it all. Feel free to contact me if shoot me an email and/or hit me up on Twitter. I'd be more than happy to answer any questions. A lot of people on this are from the island, so our doors are always open if you want to stop by for a visit. Thanks a lot, everybody. Have a great day.